Hey everybody, in this video I'll be going over our last learning target of the semester. Congratulations on a semester well done. We're going to finish it off today with learning target 26, where we find the volume of solids using the general method or the disk method. So these are the questions. Pretty much we're given curves, we're going to revolve it around something and give the volume of an actual three-dimensional solid. Alrighty. So let's go ahead and start with part one. We need to draw the region very carefully. Given three curves. First is y equals x cubed, and we're given that one. Next we have y equals 0. That's a line like this. I'm just going to draw on a thick black line. And then x equals 2. Just like that. So we don't really know what this x value is here. So we need to solve for that. What we're going to do is plug in this x equals 2. This equation here, we get y equals 2 cubed, which is equal to 8. 8 right there. This is not part of our solid, let me be clear. That's just helping us understand what bounds we might end up using with our integrals. So that's our region R. Part 2, we need to set up but not evaluate the integral representing the volume of the solid obtained by revolving this region R. In the first case, we need to do it about the x-axis. The x-axis. So, using the general disk method, we're going to recognize that there's some radius and we're going to be revolving that. So our volume will be the integral from 0 to 2 in terms of x. We're going to have dx. And that's just the area. And the area is going to be written in terms of x. Easy enough to remember, x-axis, terms of x. So our volume from 0 to 2 will be pi times our radius squared. Does that ring a bell? Pi times radius squared? That's equal to the surface area of a circle. Area of a circle. And you may be thinking, well, we want to solve for volume. But these integral bounds, this integral, that's what makes it 3D. We're going to have an infinite amount of circles. But we're going to be like looking at the circles, like from our radius right here. Circle, 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 circle. In this case, it'd actually be like this. We're looking at it from the side. And these circles, when you stack them on top of each other, all the way like this, then you get a 3D volume. So our radius in this case, that's the last thing we need to figure out. Because we have our integral bounds, we have pi times the radius squared. Our radius, like our height, is just going to be the x cubed expression. It's going to be squared dx. Now we need to do the same thing about the y-axis. In this case, we're going to have a different radius. With the y-axis, our radius looks like this. But it's not exactly going to be as easy as that because we're revolving it around the y-axis. We're going to have an inner radius, our inner, it's like that, and an outer radius. I'm going to get rid of that inner line actually. Inner radius and outer radius. Because when you subtract those, that's the area inside of the region. And since we're revolving about the y-axis, everything's going to be in terms of y. So our bounds will be from 0 to 8, as 8 is the height. Area in terms of y, dy. So instead of just pi times the radius, we'll have pi times the outer radius squared minus pi times the inner radius squared dy in terms of y. And plugging those functions in, you need to think a little bit about what these radii will be. So the r outer one is pretty easy. That's going to be this constant, not the ruler there. It's going to be this x equals 2. The outer radius is just 2 squared. But our inner radius is when you think a little bit more about. Our inner radius is the function y equals x cubed, but we're dealing with terms of y, so we can't write it as x cubed. What we need to do is write it in terms, we can't write it in terms of x. What we need to do is write it in terms of y. So solving for x, we get the cube root of y. So that's how we're going to write it. That's still squared. This is all dy. This is definitely one of the more confusing topics that you'll learn in calculus. Let's get through this one more time. First thing we're going to do is understand the region we're dealing with, bounded by the curves. So we're given y equals x cubed, y equals 0, and x equals 2. So we need to draw those vertical line at x equals 2 and the horizontal line of y equals 0. And then in terms of our bounds that we'll use later, we need to recognize what this point is right here. We do that just by plugging in the x equals 2 into our equation for y. We get 8. When we revolve around the x-axis, we want the volume to be written in terms of x, dx. And the bounds will also be on the x-axis, 0 to 2. Our area is going to be pi times the radius squared. We're thinking like a bunch of circles, and we get volume by stacking them up on each other. And our radius in this case is just going to be the height from the x-axis to that curve y equals x cubed. So plug in x cubed there, and we get our volume equation. About the y-axis, we're doing things in terms of y now. So our bounds are from 0 to 8, the height. But at a given point, this is not part of the region, but this is. So the way I write it is by having an outer radius and an inner radius. And we do that by subtracting the outer or the inner radius from the outer radius. In this case, the outer radius is that constant, x equals 2. And our inner radius will be the curve y equals x cubed, but we need to write it in terms of y. So we solve for x in terms of y and plug that in. Hope this